Band theory for semiconductors. Different substances have different properties like their luster, their chemical properties, their strength, or their conductivity. We have different models to explain different behavior, like electron C model for metals. For covalent bonds, we have molecular orbital theory. Similarly, conductivity of substances, particularly semiconductors, are best explained using band theory. Isolated atoms have identical energy levels 1s, 2s, 2p and so on. But when these atoms come closer, these identical energy levels split into bands. As you can see here in the diagram, the 3s energy level, which for all identical atoms have same energy level, split into energy levels having different values. Similarly, the energy levels present in 3p orbital also split into different energy levels for different atom. The main reason being that no two electrons have exactly same pattern of surrounding charges when atoms come closer to form solid, and therefore having different energy is obvious. When the gap between atoms in solids become even lesser, these energy levels, which by now are formed in bands, start overlapping with each other. As you can see here, they are overlapped. In substances which have even lesser separation between atoms, these band gaps further arises. You can see here the energy levels form proper bands having band gap between them. The uppermost energy level or the band which is occupied by valence electrons is called valence band. That is, valence electrons reside in the energy band called valence band. And the next higher energy band, which is empty, is called conduction because electrons, when reach these energy levels of the conduction band, are free electrons and participate in conduction. Based on the formation of bands in solids, they are classified into conductors, semiconductors, and insulators. Like in conductors, we have the band gap, that is the gap between valence and conduction band of less than zero point 0.2 electron volt. Whereas in semiconductors, you have the gap between zero point 0.2 electron volt and 3 electron volt. For insulators, it is larger than 3 electron volt. Like silicon, which is a semiconductor, has this band gap of 1.1 electron volt, whereas germanium has band gap of 0.7 electron volt. This is why silicon and germanium have lesser number of free electrons in their conduction band and hence are poor conductor than most of the conductors like copper, aluminium. They have the band gap less than 0.2 electron volt or in some cases overlapping bands. Valence electrons which are present in valence band, coincidentally for silicon and germanium, which have 4 valence electrons each, all lie in valence band, that is their valence band is completely filled, whereas their conduction band are completely empty at 0 Kelvin. In next video, we will explain how these electrons reach into conduction band and how these electrons in different bands help in conduction of semiconductors. Thank you.